Okay, welcome. We're going to go through antibiotic questions now. Explain what is meant by bacteriostatic and bactericidal antibiotic. Get a mark for saying that antibiotics kill bacteria. Get one for saying it prevents reproduction if it's bacteriostatic, or division or growth. That would also get you the mark. Bactericidal. Now, I accidentally put an O in there. You can appreciate why, but it's definitely bactericidal, which kills bacteria. No extra detail related to bursting there. So then you've got the MRSA infection rates for ABCD hospitals over, it's quite dated, isn't it, to March 2005. And you're asked to compare the rates of infections in A and B. So I've just immediately highlighted that. Perhaps I would get a highlighter pen and go over it if I had one. So I've written same at start, same at end. So you're really, each point again is comparing it. B is higher than A most of the time. Would you agree? B is higher than A most of the time. Comparative figures down there. B is often double the number, e.g. in April 2002. Okay, so, or that much higher, you could say, using figures. So there's always a mark for comparative figures. B rises then fall, A falls then rises. So B rises then falls, and A falls then rises. That's a good comparison. Both fall after April. So there you go, they're both falling there. Okay, next question. What about D? D is consistently lower rate. Some of you wrote low, but it's got to say lower. That's a comparison statement. There it is, consistently lower. Why? D is stricter hygiene practices, e.g. better hand washing regime, has antiseptic solutions available, e.g. alcohol. You can see that's 4 marks straight away, just for that detail. D isolates suspected cases, screens on a mission. A lot of you got that, so that's great. D has fewer patients. Some of you got that. Fantastic. Next question. So you've got the features, makes you realise how much you need to know about these. So you've got bacteria, glycogen granules and bacteria only, nucleic acids, of course both, you know, DNA and RNA and viruses, and DNA and bacteria. The capsid is only viruses. BRD cases can be used, can be treated with antibiotics. However, up here in the stem of the question, the most severe cases of BRD involve infections of viruses and bacteria. So they're saying, why not just antibiotics? You're saying, well, viruses are involved and they need antivirals. Actually, there's 2 marks in there. So there's another dash. Antibiotics are only effective against bacteria. Then you've got the cases, and then obviously testing 3 different 6 different antibiotics that look familiar after us doing our practical, and 3 different bacterial species, and they're asking you which is the most effective. So give reasons for your answer here. Suggest which antibiotic would be most suitable to use to treat these cattle. And actually the answer is the 2 of them. So you've got to list both of them for getting the first mark. And there's 3 marks available. And the reason being is, look, that all of them are over 83%. Okay. Is there another mark? I can't remember. Yeah. Oh, I know. It's just simply stating that they've got the highest percentage of pathogens being killed. Figure over 83%. Next question. Suggest why it might be advisable to change the antibiotic being used to the treatment of these cattle once the pathogen has been identified. Well, simply none of them are actually 100% effective. If there is an antibiotic that is 100%, then this would be better. As they're not 100% with the current ones, it means that some bacteria are resistant, and resistant strains will develop if you keep using this. Okay, that sense of the antibiotics not being useful. Okay, next question. You guys did pretty well with this. So antibiotic used to treat bacterial infections in eukaryotic organisms. Then a sense of, do bacteria have mitochondria? No, they're prokaryotics. It's only found in eukaryotics. Both have flagella. Remember, the sperm has so eukaryotic cells in us has a tail. All bacteria have flagella. Small circular loop of double-stranded DNA. Plasmid, just the prokaryotic, so the bacteria have that. If vancomycin kills the bacteria cell, it's definitely bactericidal. Suggests how it kills it. Cell wall weaker, cannot form, cell bursts during division. I remember Pan was asking a relevant question about this. So how does it happen? So the idea is it's trying to get bigger, and when it gets bigger before division, that's when the cell wall isn't formed. Okay, so it bursts before it even divides. Explain why doctors have been advised to limit the prescription of antibiotics. Some bacteria are resistant. When you add an antibiotic, you're adding a selection pressure. I use that term more when we do evolution at A2. Resistant bacteria survive and pass on that resistance to their offspring. Okay, so it's a real evolution question there. Then the antibiotic is no longer effective. Okay, so then describe how they investigate the effect of different antibiotics. The lovely practical that we did. You've got a petri dish, even distribution of bacteria like a lawn spread. Use aseptic techniques the whole time. They could ask you a question related to what steps would you do to ensure it was aseptic. You'd say things like have the Bunsen flame the neck of the bacteria, use an inoculating loop and put it in the Bunsen, allow it to cool, obviously. So you add a multi-disc antibiotic plate onto the agar, which has got the bacteria now on it. Equal concentration of antibiotic in each. I know we mentioned that. It's a very important control variable. Incubate at 30 degrees Celsius, so it just says just a suitable temperature. And the way you assess it is by assessing the zone of inhibition. Okay, like with a ruler, we measure the diameter, so some indication of that. Then, of course, repeats. We had everyone in the class doing it, so we had repeats. But then that also the concept of you could repeat with different bacteria as well. We did it just with E. coli. That sentiment of just you could then go on to try it with different bacteria. So next question is about the skin. Important non-specific barrier, isn't it? Why, if you've got some skin flora, why is that good? And it helps you from infections because, of course, the skin flora is going to compete for space and for nutrients. A lot of you put that on one line together. What have I written here? And they also, as a third point, secrete chemicals. They might affect the pH, so pathogens can't thrive there. Part of the skin that forms a physical barrier is the epidermis, and that reminds me, actually, I should go over the structure of the skin with you. We'll do that more with thermoregulation with Unit 5. So flu, basically saying that sometimes, even though it's a virus, they use antibiotics, and it's a sentiment that bacterial diseases may arise as a result of your immune system being impaired whilst you've got a virus. Then you need antibiotics because antibiotics kill bacterial diseases. These diseases that arise, like with HIV, when it goes into AIDS, you get opportunistic infections. So this term could be used again. So overuse of antibiotics is a big concern. Number of prescriptions per 10,000 of the population. You can see, it's gone down. That's a good thing, isn't it? I wonder where we're at in 2014. So the calculation is percentage reduction. Now, percentage reduction and percentage increase, it's just a simple formula that you have to learn off by heart. It's the difference divided by the initial times 100. So from 2000 to 2006, the difference is 226, take away 142. There it is, 226, take away 142, divided by the initial, and that means, the starting value. So divided by 226 times 100, and that's 37%. And I would just look at that and go, does that look right? Okay, so if it was 113, do you think that would be a 50% decrease? But it's more than 113. Yeah, that looks about right, doesn't it? Okay, so the target set for 2012 is 128. Are we going to get to it? 128? Hell yeah. Okay, so yes is a mark. Can you believe it? If rate continues, if the same rate continues, we'd actually would achieve even lower. And then quoting some figures, so what you'd actually achieve by that time. Suggest why health authorities use in the USA are encouraging the reduction in the number of prescriptions. Same again. Some bacteria are resistant to the antibiotic. If antibiotic used, these bacteria will survive and pass on their resistance to their offspring, e.g. with what happened with MRSA and Clostridium difficile. I hope that's helped.